Hello, good morning. So today we are going to learn about few calculations regarding noise. So as a safety professionals, we certainly, some might know, but most of the people are not aware of this concept on how to calculate noise. Normally, let's say if in an area, let's take there are four equipments, one, two, three, four. So in this area, let's say there are four equipments, okay? And each and every equipment is generating one sound, okay? Like 85 decibels, say 90 decibels, and let's take 97 decibels, and let's take 102 decibels, okay? Now, what is TWA of noise? See, there are two agencies which gives us two different values. OSHA says the TWA of noise is 90 decibels, whereas ACGIH, okay, the TWA they say that it should be 85 decibels. Well, whichever is lower is certainly better, but yeah, so these are the TWA levels which are posted by these two agencies. Now, how to determine the total noise in that area? So some people say you take average of these four levels, then you'll get a cumulative noise level. Okay, let's take an average and see what happens. 85 plus 90 plus 97 plus 102 decibels. So that will be equal to, if you add all those things, you'll get much. You will get approximately 312. Sorry, let's see. 85 plus 90 plus 97 plus 102, 374. What do you get? Is 374 divided by 4, divided by 4. So what you get here is 93.5 decibels. Okay, if you take average. Okay, let's see whether it is a right answer or not. So what I would say is this is absolutely wrong answer. We will see why. Okay, now let's take for example. Okay, so this is the limits we have, which is 85 dB. Okay, second thing is 90 dB, and third one is 97 dB, and fourth one is 102 dB. Now we have a certain formula that we should use to find out the total noise level. Okay, so that formula is L into Pt, that is P total, equal to 10 log of summation of I equal to 1 to n, how many number of levels it might be. Okay, so this is the formula we will use, equal to 10 lpi divided by 10. Okay, so this formula you can get it from any of from BCSP formula sheet. Even you take 8's textbook, you will find this formula. Okay, so how to use this formula? Now we are having four different values. Okay, so that means here 10 log of, that is, so first value you will have to substitute here in this LPI, whereas I equal to 1 and we have four values. So first value you will submit here. Okay, that is 85 divided by 10 plus 10 to the power of 90 divided by 10 plus 10 to the power of 97 divided by 10 plus 10 to the power of 102 divided by 10. Now if you now try to solve this equation, okay, we'll have 10 to the power of 8 by 8.5 plus 10 to the power of 9 plus 10 to the power of 9.7 plus 10 to the power of 10.2. 10 to the power of, now if you solve this particular logarithm, you will get a value of 10.34, that is equal to 103.4 decibels. Okay, So this is the exact value of a cumulative noise level. Okay, even if you take 4 machines, even you have 5 machines, even you have 10 machines, this is the way you will have to find out the cumulative noise level. So some people will say, sir, we have to take all these engineering calculators and we will have to calculate. So it becomes a bit difficult task, right? So in order to simplify this, we have one more solution. Let's take the same values, which is 85 dB, 90 dB, 97 dB, 102 dB. See, this is a shortcut which you can do even without calculator, and you can solve it very easily. No confusion. Okay. So in this, what I will say is you take any two values and take difference of those values. Okay. If the difference is 0 or 1, if the difference is 0 or 1, then you will have to add 3 to the highest value. Okay, you will have to add 3 to the highest value. And if the difference is 2 to 3, then you will have to add 2 to the highest value. If the difference is 4 to 9, you will have to add 1 to the highest value. Highest value. Okay. Similarly, if the difference is greater than 10, you will have to add 0 to the highest value. Okay, so let's do this here. If you subtract this 2, the difference is 5. Okay, so if 5 is in between 4 to 9. So what you will do is you will add 1 to the highest value. So what you will get is 91 dB. Then you take these two values. What is the difference? Is approximately 6. So what you will do is add 1 to the highest value. Okay, then you will get 98 dB. And if you see the difference, 98 minus 102, it is 4. Then you will have to add 1 to the highest value. Then you will get 103 dB. Okay, see, in our previous logarithmic way of approach, we have got 103.4. If you round figure that number, it is 103 decibels. So more or less this is very accurate way of finding a cumulative noise level in a certain area. See, normally now we know, okay, the easiest way of finding noise. Now we know the TWA. TWA. What is the TWA of noise as per OSHA? As per OSHA, it is 90 dB. Okay, as per ACGAH, it is 85 dB. Okay, so but just by seeing that, we know for sure that any person working in that area is overexposed. Okay, but how will you know whether he is overexposed or not? How much time he can work in that particular area? How we will know? So in order to find that, we have another formula to find out how much time he can be exposed to that particular noise. That formula is T. T is time here. 8 divided by 2 to the power of L minus 90 by 5. And don't get confused here, this 90 is nothing but the TWA. Okay, if we have mentioned 90 here because we are taking OSHA TWA. If you are taking ACGH TWA, you can rewrite the formula as 8 divided by 2 to the power of L minus 85 divided by 5. If you go look at some formulas, you might find this formula or you might find this formula. Don't get confused. See, it depends on what TWA you are having. So in terms, if you want to rewrite this formula again, you can rewrite as time in hours, okay, is equal to 8 divided by 2 to the power of L, which is a cumulative noise level or the total noise level there, and L of TWA. So this will erase your confusion. Okay. So let's input our values. The value what we got here is 103 dB, right? So if we need to calculate time in total, 8 divided by 2 to the power of 103 dB minus 90 divided by 5. That is equal to 80 divided by 2 power of 103 minus 90 somewhere like 13 divided by 5. Okay, and 8 divided by 2 to the power of 13 by 5 is approximately 2.6, and that is 8 divided by, it is like 6.06. So if you'll calculate 8 divided by 6.06, you will have 1.32 in hours. So if any person who enters into that particular area can safely, okay, he can be exposed till 1.32 hours. That is the time duration he can spend there. Okay. So the next question is whether he needs hearing protection. Yes, he needs hearing protection. Then we are going to reduce the value of the exposure. Okay, hearing protection is certainly necessary. We should not make arguments such as no, because we are finding time, the time of exposure can be 1.32 hours, no need of exposure protection, no need of hearing protection. No, hearing protection must be there. This is just to make sure that he is safe in any matter. Okay. So this will tell you that yes, we can spend time there, but hearing protection is must. Okay. So now you can complete this task. Say for example, if there is a very big room, okay. Now say one, two, three, four, five, six, seven equipments are there in that particular room, and each one is generating its own noise level. Okay, 60 dB, 72 dB, 80 dB. Let's take 85 dB, 105 dB. Let's take 101 dB and 97 dB. Now you will have to find out the cumulative noise and what is the time duration of exposure. Okay, and in this way you can do easy assessments, okay, at your work site. So for more noise related videos, there are many other formulas as well. The way we have to assess the whole area, noise mapping and all. You can just show your interest so that we can make more of such videos. Thank you very much.